Hey everybody, it is now time for part two of our five-part series on atoms, or how do we know what we know. As mentioned in part one, we're going to be looking at these three main learning intentions right here. How did the idea of atoms originate? What evidence do we have that atoms even exist? And three, how has the model of atom evolved over time? Part one, we talked about Democritus, and you should have read about Aristotle. If you have not done that, you can go back and do that right now. But today we're going to be talking about what evidence do we have that atoms even exist. Again, I'm Mr. Zimbrick, and we have our special guest back over here that I just want to introduce you to again. Okay, so what we're going to be talking about today is a guy named John Dalton. He lived in England in 1760s through about the 1840s, so roughly, 200 years ago. And he essentially was one of the first scientists that really got into some of the math and calculations behind atoms. What he did is he used very precise scales and measurements to look at different substances that he collected. And he would weigh them and he could calculate essentially proportionally what different elements they might be composed of. So if he might take, like, say, a certain type of red powder that he knew had chromium in it and he knew it had oxygen, and he'd weigh it, and then he could break it apart and then come up with, roughly, he would say, okay, maybe this is 1 part chromium, 3 parts oxygen. He would do experiments like that and kind of, he was able to essentially come up with the mass of different elements. And he said that an element is basically 4 different things. They are elements are extremely small particles called atoms. He said that atoms of a given element are identical in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. And last but not least, in chemical reactions, atoms are combined, separated, and rearranged. So essentially, we've talked about the conservation of mass before. And one of the things that he said is that mass is conserved in chemical reactions, whether it's burning or even something like photosynthesis or respiration. And it's conserved because what is actually happening is it's just atoms that are recombining in different ways. And so maybe we're taking atoms out of the air and adding it to a solid substance, or maybe we're taking a solid and it's burning and it's becoming a gas. But really all that's happening is the atoms are being rearranged and separated in different ways. And so he was really on the forefront of this. We talked previously also about the scientific revolution. We talked about Copernicus, Galileo, and Newton. And he was essentially kind of like one generation after these guys. So he was around right when a lot of real science started being done. We can look at this little part right up here, and we can see that he was actually doing experiments. He was using very precise scales that he had developed. He was taking measurements, and he was using math and logic to come to his conclusions. Essentially what he said, and he made a model of atoms that looked something like this, was that atoms were just these spheres, and they were kind of homogeneous spheres, and they connected somehow. He didn't know how, but they connected. Water, for example, he knew was 2 parts hydrogen, 1 part oxygen. And so he might draw something like this with 2 spheres of hydrogen and 1 sphere of oxygen. And then in his model, he said they just hooked together somehow. And he actually made these out of wood, and he took metal, like metal wire, and hooked them together. And he said that's what water was. It was hydrogen hooked on to oxygen. And that's basically the furthest he got. He didn't know how they connected. He didn't know what made them different. He just knew they had different masses and they could connect. But he couldn't explain why. But that was basically one of the most or earliest atomic models that really had some evidence for it. He knew the mass of hydrogen, he knew the mass of oxygen, and now some other scientists had to answer these other questions. So we're going to pause there today. This is, again, part 2. And today's Nature of Science reflection point is going to be that individuals and teams from many nations and cultures have contributed to science to advances in engineering. We're going to think today about how do individuals from various nations and time periods add to our scientific knowledge. Today I talked about just one guy, John Dalton, but you are going to go into Investigation 3 from the Big History Project, and you're going to read about some different people, including Mendeleev and Lavoisier. You're going to look at what evidence they had to come up with the elements and atoms, and you're going to think about how is their work different from Aristotle and Democritus, who came before them. So again, what I want you to do now is go to Investigation 3 in the Big History Project, read text 2 through 7, and then you're going to write up paragraph 2, which should be about the findings of Dalton, Mendeleev, Lavoisier, with a little bit talking about how these different individuals and different time periods may have contributed to our scientific knowledge. All right, that is it for part 2. Thank you, and go get to work.